In grade 9 and in grade 10, one of the things you're asked to do is draw a Bohr model for an atom. And students usually don't have any trouble memorizing the rules for how to draw a Bohr model, but I just want to take a minute here and try to explain where it came from. So Niels Bohr was a scientist who looked at elements through a spectroscope. A spectroscope is a device that you would have seen in grade 9. It's got a prism inside, and what it does is it splits the light into its specific wavelengths so that you can see each component of the light that's coming from the object. So Bohr, if you look at white light through a spectroscope, you're going to see all the colors of the rainbow, the Roy G. Biv colors, because it's a continuous spectrum. Similarly, if you looked at a white light bulb, or if you looked at the sun, you'd see all those colors, all those wavelengths. But when Bohr looked at just one element, hydrogen, actually it was hydrogen gas, he didn't see all those different wavelengths of light. He saw only very specific wavelengths of light, and that's these bands of color here. This is called an emission spectrum for hydrogen. So how did Bohr get from there to his model of the atom? Well, he knew where the light came from. The light came from electrons that were jumping from one energy to another. So if we make a little sketch over here, we'll say this is our nucleus, and when an electron is found at a higher energy level, it has a higher energy than when it's found at a lower energy level. And when the electron falls back to that lower energy level, that extra energy has to go somewhere. Where does it go? It gets released as a photon of light. Okay, so once again, the electrons, when they're further away from the nucleus, they have a higher energy, and when they fall back closer to the nucleus, they release that extra energy as a photon of light. Now, what Bohr noticed was that only photons of very specific wavelengths were emitted. That means that these electrons are not found sort of all throughout in this big cloud around the nucleus. They must be found in very specific energy levels in order to release very specific wavelengths of light. So in other words, you might find an electron at this energy level, you might find an electron at this energy level, but you're not going to find an electron anywhere in between. And the word for that is quantized. And so Bohr said that the energy of the electrons in an atom is quantized. And so that's where he came up with this idea of energy levels, or shells, that the electrons must be found at. Now later on in grade 11, you'll learn sort of why we have 2 electrons in the first shell and 8 electrons in the next shell, etc. But for now, just knowing where this idea of shells came from might be useful.